This. All right. Welcome in to the fifth class in our C# for gamers and streamers. We didn't do it last week or the week before, so we're a little bit we're a little bit rusty, I guess. So we'll try to sneak back into this slowly, but we got a great class for today. Object-oriented programming in C#. We're going to talk about what are classes, what are objects, what do we do with this stuff, how does it help us, what are all the ins and outs. We're going to talk about all that today. I absolutely love object-oriented programming. It's got its benefits and its downsides as well, but I think it's really a great thing for programming. It came about after a lot of the early programming languages were established, and it really helps you to wrap your mind around what the computer's doing. So it's giving us this kind of abstraction layer between how humans think about programs and things in the real world, and how computers handle those things. So we have this kind of abstraction layer where we can deal with objects which are easy for us to understand, and the computer can deal with its assemblies and ones and zeros and blah blah blah, caching and all that, and we know what we're talking about and it knows what we're talking about, and we get along really well. So that's why I love object-oriented programming. It makes things a lot easier to conceptualize. Most things are written in object-oriented programming, especially games. Nearly every game is written in object-oriented programming. The only reason you wouldn't really use it is because you need some level of efficiency within your game. So, for instance, if you have like 1 billion objects on the screen and you got to keep track of them all, you're probably not going to use object-oriented programming, or if you do, you're going to have to really do a lot of memory management and stuff, because it'll easily overload your resources on your computer. But nearly every game in existence, at least modern games, nearly every modern game is written using object-oriented programming. So we're going to get into that today. We've got a great class. This is going to be fun. And we will see how we do. Now, that being said, you struggle with Googling how to find the largest, smallest. All right, so this is gonna blow your mind. All right, this is gonna blow your mind. Not really, but you may be kicking yourself when you see the example. And my watch is doing weird things. Hello, watch. Okay, I gotta open my phone, fix my watch. Hold on. What is happening? Stop it. There we go. All right, sorry about that. All right. Here we go. Let's pull up the deal from last time. Googling it gave you all too overcomplicated answers. Okay, so let's look at it. So last week's take-home puzzle said write a program that stores a list of numbers. So that's something we should be able to do. We'll go ahead and get started on that, because we'll have to write out a list of numbers. And we'll go ahead and do that. So, excuse me. Let me move this to the side so I can see the chat here. All right, so we need a list of numbers. we will make a list, and we'll just take some pre-existing numbers, and we'll go ahead and do this in the program here. So let's go ahead and go into main, and we're gonna say we're gonna make a list of ints. We'll call it numbers equals new list int, and in here we will assign some numbers, and I'm going to use Pratchett's numbers just as an example here. 6 3 2 8 1 5. Close that. Close that. All right, we should be good. Should have some numbers here. So then what we should be able to do is sort. So that was our first thing we wanted to do was sort and display the list, okay? So you need to be able to sort it and display it. Well, we know that we could take numbers dot sort in order to sort that. That's all I got to do. To sort those are now in alphanumerical order, and in this case they're ordered 1 2 3 5 6 8. Okay. Now we want to display them, and this is one of the areas where we got into trouble. So let's take a look at that. So there are quite a few ways to display a list like this. The most straightforward way, that's kind of the old school way, is to use either like a for loop. So you can say for, oh my goodness, my keyboard's killing me. For int I equals, or no, for, yeah, int I equals 0, we'll say. Int I equals 0. I is less than numbers dot count I plus plus, right? And this is your old-fashioned for loop where we're just iterating through, and we can say console dot write line I. There we go. So if we run this, we should get them sorted 0 1 2 3 4 5. Okay, I'm a dummy. I got ahead of myself. We need numbers sub I. Look at that. I told you I was rusty. Okay, there we go. 1 2 3 5 6 8. There you go. That's the old-fashioned way to do it. A good old for loop. Easy peasy. Now, this is a lot to write, so it's easier to say for each int I in numbers. We could say this, and this does the for loop for us, and we're done. Except that I have done something horribly wrong. Oh, because yeah. We just need I. We're not iterating I anymore. I should have said, for clarity here, I should have said number in numbers and then use number here, because we're not actually using the index anymore. We're using the number inside of the for loop. 1 2 3 5 6 8. So this is actually right here. This for loop is pulling the actual element out of the list. This isn't the index like it was with the for loop. Okay, so we could just write the number and we're done. Now we can get even fancier, and that's what we like to do. We like to get fancy. And I noticed that Pratchett was trying to do something fancy like this, most likely brought upon by Google. So let's take a look at that. So we can use the list class has a method called for each. We can actually use that method to iterate through the list without having to create a for loop or a for each loop. And the way we do that is by saying numbers dot for each. Now we need, just like in our for each loop. Okay, let me see. Let me go back to that actually. So in our for each loop here, we had this number. We had a defined number. And number is coming through here, and it's taking each number out, each element out of the list in order, and calling it number for that loop. So the first time it goes through, this is a sorted list, so this will be 1. It goes through, and the number is 1, so it prints 1. Then it goes through again, and it's 2, and it prints 2, 3, 5, 6, 7, 6, 8, as you get it. So we need this number. We need to find this number so that we can do stuff with it. Well, the same thing exists within the for each method. Oops. And the way that works is we can take numbers dot for each, and then we take this thing, so we'll say number for each number, and this is actually something called a delegate, which just know it stands for whatever is inside of the loop. That element in the loop at any given time is going to be replaced by a delegate, which is number in this case. And we're going to use this little assignment operator here, the lambda symbol, or whatever you want to call it here. This is going to give us the ability to write whatever single line command we want to do using this number. And in this case, we want it to be console.writeLine. So we're going to say console.writeLine, and we'll put number in there. And then we got to close this for each loop and end it with our statement with a semicolon. And that's it. So this should work the same way. So we can go ahead and run that. And there you go. 1, 2, 3, 5, 6, 8. This is just another fancier way of doing the for each. This is actually a method within numbers, so it's a little different. It has context for this this list, but really we're just making our for each loop a little, basically make it one line. That makes things easier. This allows us to do crazy things because we can combine this with other things within the single command. So we don't have to, we don't have to like have a separate line for our for each loop here. We could do a thing here and then put this whole thing within one big long command. It may or may not be the way to do it, depending on what you're writing at the time. But this allows us to do some crazy things without having to use these brackets and stuff. So that is another way of doing it. All right. So there we go. We've sorted the list. We've printed it out. Now, what else do we need to do? Next, we need to find the largest and smallest number. Okay. So this is not tricky at all. If you're thinking about the structure of your data. Okay, so I put numbers.forEach console.writeLine, and it seems to work. That's it. Probably does. So what you can do, the for each will allow you to use in this case, because numbers contains ints. Any method that will take an int as a constructor, you could technically just put it in there and it'll do it. So I could put console.writeLine here, and it's going to assume everything. It's going to assume my my delegate. It's going to assign that delegate to the constructor of console.writeLine. And as long as there's a constructor in my method that takes a single int, it's going to just work. So I can do this and it'll work. I could have done a lot of things. So in this case, I could have done void. We could just do void print in this case, just as an example. And I need my constructor here, so we're gonna void print int I. Okay, void print int I, and then I can come down here and say console.writeLine I, like that. And then if I put print here, this will work. There you go. And the reason for that is it's going to assume this method is going to basically assume all that stuff that I defined earlier. So that's the way it works. I want you to understand the idea behind this. So just putting like console.write here, WriteLine, doesn't really tell you how this is working. But what it's doing is number, this right here, this number, we don't have to define this as a variable for a delegate, but something like this exists when you get rid of that. Okay. Now this will become important. So this would become important if I wanted to do something like this. Right? Oh, wait. I've got in. If I wanted to add 3 to all of them, I can't do that if I don't have this delegate created because I have nothing to use here. So that's another thing to bear in mind. This is always existing, but you can't reference it if you don't actually put it here. So I would not be able to add 3 to these numbers at all. I couldn't do like WriteLine plus 3 or whatever. That I can't do that. So that's how that works. There's lots, especially with these lists and stuff, there's a lot of little tricky things that you can do. They're designed as ways of storing data, and they have lots of little things. We've got link that we can use that helps us do a lot of the things that we'd want to do with lists. Which is why I encourage you guys to go out and take a look at lists and all the things that lists will do, because they will do a lot of things. All of those enumerables and collections and stuff, they all have these fancy properties. All right, so here we go. Next, we need to find the lowest and the highest numbers. Okay. Well, how can we do that? Well, there's a couple ways to do that. Number one, we have a sorted list. That makes things super easy. How do I know what the smallest number is? Well, it's going to be the first one, right? I can say console.writeLine, and then I would say numbers sub 0, and that's going to always be the lowest number. I'll say lowest number. All right. And the same thing is true with the highest number. Okay. Oh, Atom Smasher, what is this? Because we're using a zero index, we need to subtract 1 from the total length, which is what this is, of the list. So if I have a list of 1, 2, 3, 4, 5, 6 elements, then I want to see what's in the number 5 index. Okay, because this is 0, 1, 2, 3, 4, 5. So take the total of length of the list, and I subtract 1, and I pull that number out, and bada bing, bada boom. I've got the highest number in the list because it's sorted. Oh, Atom Smasher, what if I didn't sort the list and I still want to know the highest and lowest? Man, am I glad you asked, because there is some fantastic stuff available to you. Like I said before, there are lots of fun things that we can do with lists, okay? So let's take a look. Let's say we don't have a sorted list. We can't do this, right? It's random. We got random numbers. We don't know. We don't know which one's highest. We don't know which one's lowest. We don't want to sort it because that's a waste of our time, and we've got to keep our numbers in order, okay? But we still need to know the highest and lowest. Fine. How do we do that? You're going to love this. You're going to love this. We got to use system.link. Which apparently we can't use. Wait a minute. Oh wait, no, I'm just stupid. Haha. Yes, I'm stupid. There we go. I left out my parentheses. I was confused. Alright, there you go. Min and max. Bada bing, bada boom. What does this do? Let's see. Ta-da! 1 and 8. I can just not sort this list. And it'll be in random order, and I'll still get 1 and 8 because these wonderful, amazing, incredible, super awesome methods will just give me what I want immediately. No problem. You're a wizard. Yeah, I'm a hairy wizard. All right. Now, what's next on the list? We've got remove duplicates using hash set. Oh no, the dreaded hash set. Where did that come from? We're doing some review. Okay? We need to add some duplicates to our list. So we'll add a 5 and a 3 and an 8 to our list here. Okay. We need to remove duplicates by using a hash list. So how do we do that? Well, if you remember, we can establish a hash set by saying hash set. We'll call it hash nums We gotta do int here. Hash set int hash nums equals, and we're gonna convert it. Does anybody remember how to convert a list of ints to a hash set of ints? Do I remember? No. Okay. So, I showed this in the last one that we did, and all you have to do is when you're defining your hash set, we'll say new hash set, and all you have to do, watch this, in the constructor, the hash set class has a constructor for collections, so we can put our list of numbers directly in here, and it will not work because I did not include int. Again, my brain is clearly not working today. Okay, there we go. Hash set int hash nums equals new hash set int numbers. Ta-da! And now we can print this one out. Hash nums dot for each. Oh, it's angry. All right. We actually need to do. I'm not. Okay, now I'm remembering something about hash nums that I think we talked about last time. Let's see, hash in hash. Yeah, we can't use for each. No, we can. We can totally use it. It's fine. There's just not a whole for each method. All right, there we go. And then we'll say console dot write line hash num. Bam. Boom. There you go. 632815. So that removed our duplicates. Done. Next. Allow searching using contains. Haha, now we're getting into the bread and butter. So let us add numbers dot contains. Now, what can we do? What do you think? What are we going to be able to do with dot contains? Any guesses? Find something contained, yeah. Yeah, so what do we in the list? Yeah, so what should we put here after this open parentheses? See if you can guess. What should we put there? What should we put behind this parentheses? What do you think? You can say whatever you want. Ooh, there's no judgment. I just want to see if you can guess. A number? Okay, let's try that. So we'll put We'll put, what, 6 here? That's in our list, right? All right, let's see. We need to, this is going to be, dot contains is going to be a Boolean, because we're asking if it contains it, right? So let's say console dot write line, and let's see what comes out from this. Ready? There it is. So it's true because our list has a 6 in it. Then this returns true. What if I put 4 in here? False, right? Because there's no 4 in our list. Okay. I would have to put something that's of the type inside of numbers. So I can't put like 4 in here because this has to be an int, which makes sense, right? I've only got ints in my list. I need to use ints when I'm searching because there's not going to be any other type of thing in the list. All right. Okay, that was a quick one. These lists are super useful. There's a bazillion of these sorts of things that just make it work, and that's it, and you're done. So bear that in mind when you are using lists. There's plenty of resources available, and go look them up. Look them up. Go look at the documentation. Go look at W3 schools, C# stuff. There's lots of documentation out there about what you can do with lists, and take advantage of that because it will save you a whole lot of time and a whole lot of frustration if you just give that documentation a once over, and maybe keep a copy of it somewhere so you can reference it. All right, so here we go. We're done here. We'll clear this out. Let's get to today's class. Here we go. Bam. What is object-oriented programming? All right, object-oriented programming is a programming paradigm that organizes code into objects. All right, so what are objects? Objects contain data, fields, and properties, and behaviors, methods. Okay, so we've already been using objects. They are classes. And we've been using them unbeknownst to us for the most part. At least we haven't understood exactly how they function. All right, so what's the use of object-oriented programming? Well, it helps to structure code in a reusable and maintainable way. What does that mean? It means that I can set up something like, let's say I work for a hospital, and I need to keep track of all the patients that come in. Well, those patients are going to be classes. Those patients are going to be objects in the system. I know we're objectifying people already. That's what you were expecting when you came in here. All right. We are going to be using, in that example, we would be using objects to define people. So we would have a patient object, and that patient object might have something like height, weight, sex, history of, medical history, all those sorts of things, vaccinations. Those are all properties that we would have inside of that class to keep track of who this person is. We need their name, we need their birth date, we need certain other information about them. All that's going to be contained in there. Another thing that's going to be in there is who is their doctor. But their doctor may not be a name on their... It may not be a string that's a name on their object, but the doctor may be its own object. So that doctor object is going to have a list of patients that belong to them. That'll be tracked using that object with their name, maybe their schedule, when they come in, when they leave, their calendar. It may contain things like contact information. All that stuff gets put into objects. And we'll talk about how that works. But we've got 4 pillars of object-oriented programming. And those 4 pillars are encapsulation, inheritance, polymorphism, and abstraction. We'll talk about all these things today. They sound really fancy, but I promise you'll understand them as soon as we get there. All right? So first, how do we create a class and an object? Okay? Let me keep this open. All right. So how do we create a class and an object? So in this case, we've got an example of cars. We've got these cars. And we want to track a few things about the car. We're going to create a class called car. We've got a public string make. All right. So we're going to track the make of the car. So in the car world, you have makes. Those are the companies that manufacture and put their names on the cars. Your make might be a Nissan, Toyota, Ford, BMW. The list goes on infinitely, nearly. Those are your make. Okay. Then you have we have another string, model. So that would be what type of car it is. So it might be a Corolla, or a Fiesta, or a 323i, or whatever. I don't know why I named like the oldest freaking BMW I could think of. A Passat, something like that. Those are going to be your models, and then the year that it was manufactured. So that is the things that we're going to track right now for these cars. All right. So when we create that object, we have defined it. So we need to define that object as a class. That class car now exists, but it doesn't do anything. It doesn't have any information in it. Okay, it's just a placeholder for all this information. But we need to create the object. So we need to create a car type, and we're going to call it my car, and then we're going to assign it a new car using the new car, the empty constructor. Okay, so we do this. We've done this quite a few times with other things like lists. That's a class. It works the same way. We're defining a new car type. And within that, we need to assign those strings and that int. And in this case, we have to do it separately because it's not in the constructor. So we're going to say mycar.make equals Toyota, mycar.model equals Camry, mycar.year equals 2022. And that mycar will float around through our code, and anytime we reference it, we can pull that information. So we could have 30 mycars, and they all have their own make, model, and year. And they all exist inside of the code. All right. So let's take a look at that, because it won't make sense till you do it. Let's pull it up here. So we're in program here. I kind of want to have the main method. There we go. So we're gonna define a class here, and we're gonna use that class in order to run this. So we'll come in here. We're gonna make the car class car, and we're gonna add a public string make and a public string model and a public int year. Don't worry about public and all that. We'll talk about that as we go along. Okay, so just know that it's public. All right, public void display info. This is going to be a method of the car class, And inside of this method, we are going to do console.WriteLine, and we're going to have it print out all the stuff that we know about the car. So this will be year, make, model, come on, year, make, and model. We'll print out, and we want to put a space between these. All right, and we'll come down here and close the car class, and then we need to define car, and we can say car, my car equals new car, and then we could say my car dot display info. Now, right now, my car is empty. So if I run this display info, these are all going to be null. So I'll get a 0. But I can add things to this. So I can come in here and I can say, I could say my car dot make. What am I doing? My car dot make equals, and then I can say my car's going to be an Adam car. Okay. And the my car dot model is going to be the Adam car fire hair. That's the name of our model. Okay. And my car dot year is going to be a recent car, so we'll say 2025, brand new, straight off the lot. Here we go. Now if we run it, look, we get 2025 Adam car fire hair. Okay. All that is kept within this. And this my car carries this around. So I've got my car dot display info. I've established these three variables within the car class properties, and then I'm using this method inside of the class that exists inside this class to do this console.WriteLine. So I can add whatever I want as a method here. I just need to define it down here and what it does, and I can run it from somewhere completely different. And that's because this is public. Okay. That we'll talk about. When you have things marked as public, that means they're accessible from outside of the class or outside of the build or whatever. And we'll talk about what that means here in a second. So let's look at encapsulation, which is what we were just talking about. So encapsulation hides internal details and protects data. It uses access modifiers. So we've got public, private, protected, and internal. Okay? So let's take a look at that. What do each of those mean? Because they all have different things that determine how these properties and methods get used. Okay? So the first one that we've used is public. Public means as long as I'm referencing this class, I can do whatever I want. I could just assign something directly to .make and we're done. Okay, I can put whatever I want in there. That's great and all, but there's times where I don't want the person using this method to be able to just drop something directly into that property. I want it to be done programmatically. So for instance, let's say I have I've got a check object, and I want 3 people to be able to go in, and I want those 3 people to approve the check before it gets the approved Boolean. The bool, I'll have a bool is approved, and it'll be false, and I don't want it to be true until the 3 people I've designated are able to go in and approve it. Okay, then it will be approved, and I can run the check or whatever. So I don't want somebody to be able to come in and say check dot is approved equals true, bam, done. Okay, I don't want that. So I'm going to set that variable to private because I only want this class internally to be able to change that particular property. Okay, so let's take a look at how that works. So I've got this class car. We'll start over here. And we'll talk about get and set methods. So here we go. Class car private string make public string make, and notice these are different. One is capital and one is lowercase. Also, I said sting when I should have said string. My R does not work on this keyboard sometimes. It's very frustrating, but there you go. And then we could say get return make, and we could say set make equals value. Maybe I need some compressed air to clean it out. Yeah, probably. I just need to disassemble all of my keys. I think the issue is that my my switches have worn out. I need to replace the switches. But the switches on this keyboard are soldered in. So I would either have to resolder the keyboard or just buy a new one. And I think I've landed on buy a new one at the moment. All right. So what do we have here? I've got this string make. But if I say car, my car equals new car, and then I say my car dot make equals 4, I can't do this. Okay, it's inaccessible due to its protection level. So what do I need to do? Oh, now I can't do this, right? Oh, because that's a int. There we go. I should have made this a make. Let's see, BMW. BMW. So I can actually do this. I'm not editing this string directly. Notice that this is lowercase. If I made this lowercase, it won't let me do it. But because I have this make value, I can actually set make equal to BMW. Okay? So then I can come in here and say console.writeLine. Now, here's another one. My car dot make. Uh-oh. Again, it's inaccessible due to its protection level. I can't put my car.make in WriteLine, but I can capitalize it and use this make, and that's going to use this get return right here. If I run this, bam, BMW. Okay? So I have the ability, this is kind of a silly example because I'm not really doing much here. Yes, capitalization changes the so I don't want you to get confused by the capitalization. The capitalization doesn't mean anything. It just changes the variable. I could so these are technically two entirely different things just because I capitalize it, because this is case sensitive. But this could have been anything. This could have been my super awesome make, and then I would just have to change it here. And this would still work. Okay. I don't want you to get confused about the capitalization. That's just a way to kind of say that it's the same, that this is what we're working on, but we're actually doing something completely different. And by the way, I still have to have this lowercase one here. And the reason this works is because this right here has the rights to edit this because it's inside of the class. So this is private to the class, but within the class, I have full access to it. This one's public, so it's accessible within the class, and it's also accessible outside of the class. So I could come down here and I could do another one, public string make again, right? And I can actually go here and say get return make, except that I'm not allowed to do that because it's actually okay. Never mind. I'm not going to confuse you. I forget I ever said anything. That was about to get super complicated. But all you need to know is that this right here has access to this right here because it's inside of the class. Whereas up here in this other main method, this exists outside of the class. This is in my program class. It doesn't have access to private strings inside of this class. Okay. All right. We can get more in depth into encapsulation, and we will. But for now, let's look at constructors. So, constructors. I've mentioned constructors before. You've probably heard that quite a few times. But we need to look at what that means. Okay. So, I'm going to create my car class. And I'm going to have these public string make, public string model, public int year, and then I'm going to have this method, but this isn't actually a method. And the way that it knows that this isn't a method, here, let me write it out first. Okay, so this is written just like a method. But the reason I know it's not a method is because it has the exact same name as my class. Okay, so this knows it's not a method. This is actually what's called a constructor. And the way that constructors work is when I define an object of the car class, I can decide what kind of constructor I want to use in order to build that class out. So in this case, my constructor is going to take a string for the make, a string for the model, and an int for the year. And it's going to assign those to these strings up here. I should have done the capitalization the other way around because I did it for the first one. But notice that this make is not the same as this make. This is actually two different makes because one is capitalized and one is not. Okay, so I'm assigning this one that comes in when somebody defines the car class. They're going to send me a string, two strings, and an int. And it's going to take the first string and stick it here. And it's going to go into here. And I could make these private, actually. Which is why I would be doing this, by the way. So the reason I would be assigning these this way and not just editing them directly is because I'm going to make these private. And the person's going to create this car class right here, and they're going to take something they can change, which is the constructor, and use that to assign it to something they can't change, which are the make, model, and year private variables. Okay, so let's go up here, and we're gonna create a new car, the Honda Civic 2020. So our 2020 Honda Civic. All right, so we'll come in here. We'll say car. My car equals new car, and we'll do the constructor. So we want Honda Civic 2020. Okay, so when I run this constructor, and this is the only time I can use the constructors when I'm creating the class for the first time. The object of the class, not the class, but the object of the class. I'm creating a my car object. I can assign things using this constructor and pass them into this car class. Okay? Now, because these are private, I have no way of getting them back out again. So this is a terrible class, but this is good for our demonstration purposes. All right. So there you go. That's how a constructor works. I could put anything here. Excuse me. I can put anything I want here, and the person will have to send me all of that information. Whatever I ask for in the constructor, they're going to have to send it to me when they create a car. I could make a different constructor for the car. So I could do this right here, public car, and do nothing. And this way, they don't have to send me any information at all. They can create an instance of the my car object, an instance of the car class called my car. They can create that, and it's got nothing in it. It comes along with all this stuff. But we haven't actually done anything. But that's perfectly legal. They can come in and do this. And then let's say we have a method that lets them assign these later. They can just use that method, mycar.make, and then assign whatever. So this will know which constructor to use based on the information that I put in there. So I could say car, my car equals new car. I could say car, my other car equals new car, and then I can pass that Honda stuff in here. And this will use this constructor, and I can prove it by coming down here, and in this constructor I'll say console dot write line first constructor. And I can come down here and say console.writeLine second constructor. And when I instantiate these using the different constructors, it's gonna print. Just by defining these objects, it's gonna run whatever's in these constructors. So the first one has nothing in it, and it's gonna print out first constructor. And the second one has stuff in it, and it matches this stuff. And so it's gonna print out second constructor. So it does know which constructor to use, and you can have any number of constructors as long as they're not exactly the same. So I couldn't make another public car string make string model year. I couldn't make string cheese, string bean, and int weight. I couldn't do that because I already have a string int constructor. But otherwise, I could make a string int string constructor. I could make a bool string constructor. I can do whatever I want. I just can't use the exact same constructor more than once. All right, there we go. Next, inheritance. Okay, here we go. This is where it gets fun. So objects or classes have the ability to inherit from each other. And this is particularly useful when you have a type of something. So in this example, we've got vehicle as an object, and then we've got car as an object. So because car is a type of vehicle, I can inherit stuff from vehicle for car. And I could do the same for bus, train, airplane, blah, 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 blah. You get the picture. They can all inherit from vehicle. So what is inheritance exactly, and how is it useful? Well, let's take a look at that. So we've got our car class, but our car class, we want to be able to use something more generic. This is typically how this is used. So let's say I'm a veterinarian, okay? And I want to keep track of all of the animals that I take care of and treat. But the different animals are very different. They have a lot of things that, a fish is nothing like a dog, right? I mean, there are ways, but not very many ways that it's like a dog. But I probably want to have food for dogs and for fish. And I want to keep track of a lot of things that are universal across all of my animals. Things like medicine I want to track. So I'll have an animal class, and then within that animal class, I will have inside of that animal class, I'll have things like food and weight, owner's name, things that I would need for every single type of animal. So yeah, like the owner's information, I'd have to have for every one of the animals in my care. So within the animal class, I'm going to put all those things that are necessary. Then, and even food, all the animals need food. And all the animals have a potential to need medicine. So I put all those within my animal class, and then I would start defining things like dog, cat, fish, cow, pig. All those things would be their own classes because they have their own things about them that aren't true for any other animal. And I may need to have extra information about food for a lizard that I wouldn't need to have for a pig, because they need a particular type of food or something like that. And so that's where we can do something called overloading. So This is a big wide angle view. I want you to understand that classes have the ability to inherit from other classes, and that pretty much makes them a type of that other class. So let's take a look at this example. We've got class vehicle, public int speed, public void move, console dot write line, moving and then we close that, and we need to make a class car which inherits from vehicle. So we use this colon to tell our code that we are inheriting from vehicle. So this would be the parent and child class. So vehicle is the parent and car is the child. All right. And in the child, I've got public string model. Okay. So I've done it again. String. There we go. Model. Sting. I know it's sting every time. Okay. So within the car class, right? I can create a car. So I can come in here and I could say, car, my car equals new car. Bam. I can also come in and say vehicle, my vehicle equals new vehicle. Except I can't put a space here. Bam. So I've got my car and my vehicle. Those are both their own class. So I could just declare them just like I would any other class. It doesn't matter if they inherit something else. It's gonna be able to work. Okay. So then what can I do? Well, I've got my car. Well, my car has a string model. My car dot model equals BMW. Okay. Bam. That works great. Now my car has a model BMW, but my car has other things too. Just because this is all that's here doesn't mean it's all I can use. So I also have my car dot speed. And I can assign that as, let's say, 100. We're going fast. Although it's faster in miles per hour than it is in kilometers per hour. But we're going 100. And that's fine. So this car has a speed because it's inheriting it from vehicle. And I can say my car dot move. And if I run this, it says moving because this car has access to the move method right here. Okay. Now, what else can I do? Well, I don't want to delete that actually. I want to clear this out. I can do something really fancy. I can say vehicle my vehicle equals new car. And now I have a vehicle using the car constructor. Okay, because the car is a type of vehicle, I can take a vehicle object and I can say new car. Now, what can I do with this? Can I go in here and say my vehicle dot model? Nope. I sure can't. So even though the car class has a dot model available, I'm actually using a vehicle as my instance of that object. So I can only use what's in vehicle here. So why would I want to put a car in the my vehicle? Well, I'm so glad you asked, because this is super, super cool. There's a few reasons we can do this. Or a few reasons we want to do this. One is if I have a constructor, and I want to put the constructor under here. So I can say public car, and then I can say string model, and then I can say int speed, now I can set the speed of the car and the model right here in the car constructor. So I can come in here and I can say model dot this equals model identifier expected. Wait, what? Oh, I'm an idiot. Sorry. This dot model. So I have to do this here. And the reason I have to do this is a specific reference. That means the class that we're in right now. So why do I have to do this dot model? Well, I've got string model here, and it's exactly the same as here. So the code doesn't know if I'm talking about the model sent to me from the constructor or the model in the class if I just put model. So it's going to assume that if I write model, it's pulling the model from here. Which means if I want to reference the model inside of my class, I need to say this dot model. Because that's going to say, oh, in the class, there's a property called model. And that's what we're going to use. And we're going to make the model from the constructor equal to this dot model. It's confusing at first, but you get used to it after a while. And I don't know why I said model.this. It makes me feel like I need to take a nap. Things have been weird on the sleep front lately. So you'll have to excuse me while I make really weird errors. Which I've done multiple times today. But we correct them. And we keep moving along. Okay, so this dot model equals model. And that will assign that here. I can also come down here and say, hope you get better sleep. Oh, thank you. I could say this dot speed equals speed. And now I'm going to assign this speed here in the constructor. Okay. Then just for fun, I'll put console.writeLine. Thank you for creating a car and not just a vehicle. Okay. So now I have to come up here and I have to put in a model and a speed. So I'll put in Toyota. And this will be 30. All right. And again, we can't use model here, but we could say, speed. Because we have access to dot speed, it's part of the vehicle. or right up here. It's part of the vehicle class. So now I've got a new car, Toyota 30. Thank you for creating a car, not just a vehicle. So I've used the car constructor to make a vehicle, essentially. Now, yes, having constructors that do different things is useful, which is a reason why I might make a new car instead of just a new vehicle, even though I don't have access to the car stuff. But this gets even more useful when I've got an array or a list. And the reason for that is, let's say I want a list of all of the vehicles. I can take the vehicles that I have and put them in a list, and I don't have to make a car list just to have cars, and like just put the cars in a car list, and just put the trains in the train list, and just put the boats in the boat list. I can make one vehicle list and put cars and boats and everything in there, and then I can pull them out, and if I know what they are, if I know what type they are, which there are ways of finding that out, by the way, but if I know what type they are, I can actually convert them back into a car or a boat or a train, and then use those methods and properties within those child classes. I can actually reference those, and I can still treat the whole list like it's a bunch of vehicles, even though it's actually a bunch of cars and different other types of vehicle. So this is super useful. This is something that we have to use all the time in game development, because you'll have a character class. Well, I mean, let's take like a Unity or Godot or something, some kind of engine that you're developing for, and you're gonna be in that engine, and the first thing you're gonna have is some kind of like scene or something like that defines your level, and stuff's is going to inherit from that scene. Then you've got, in Godot, for instance, you've got nodes, and there's just the node class, which is like object in C#. So object in C# is literally just somewhere you can put anything. So any class can go in objects. So you can make a list of objects, and you could put literally anything. You could put an int, a string, a blah, 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 whatever you want. They can all go in there under object, and they can be stored that way. But in Godot, you've got a node, you've got 2D node that inherits stuff from node, and you've got 3D node, and you've got sprite, and all these things that inherit from node at the highest level. And node has all of its own properties and methods and stuff, and those can all be referenced by these lower ones, and kind of grouped according to that. So there's a lot of great things that we could do with inheritance. It makes it much easier to manage our code. It makes it way more reusable. And it allows us to not have to write the same methods over and over and over again for a whole bunch of stuff that does the same thing. All right. So here we go. Now I got polymorphism. Haha. Polymorphism. What is polymorphism? So let's take a look. Methods behave differently based on the object type. All right, so let's look at that. We're going to create a class animal. Public virtual void. Don't worry about virtual void. Speak. Console.write line animal sound. And then we've got the class dog animal, and this is going to overwrite. So public override void speak console dot write line bark. Okay, so what we've got is two different methods. Inside of the animal class, we have a method called speak. And that speak method prints animal sound to the console. Okay? But then we have a class dog, which inherits from animal. And if we just said dog.speak without putting anything here, it would say animal sound. Oops. Oh, I've really messed it up. It would say animal sound. But we don't want it to say animal sound. We want it to say bark. Okay? So we're overriding that. Alright, so let's go up here in our main method. And we're going to define a dog. And we'll say animal, my animal equals new dog. Okay, now we have a dog. And we'll say my animal dot speak. Which I have done horribly wrong because I have failed to capitalize that. There we go. I need to... What's wrong with this? Into file expected. Oh. Wait, what? Okay, there we go. Somehow I got an extra bracket in there. So, animal.speak. Remember how before I couldn't use what was in my car class because I had defined a vehicle? But here under my animal.speak, it's saying bark. It's not saying animal sound. And the reason for that is because we have overloaded, or overwritten rather, not overloaded, that's something different. We have overwritten our speak method here with the one for dog. So even though I can't access, like if I came down here and I said public void wagtail, right? And I would say console dot write line wagging tail. I can't come in here and say my animal dot wagtail. Okay, I can't actually access that. Because animal, user query.animal does not contain a definition for wagtail. Okay? But I can use speak because speak exists in the animal class. But we don't want to do what this speak says. We want to do what this one says. So when we do this override, whenever there's a dog as our animal, when I say my animal.speak, it's going to use the dog version because it's been overwritten. And this is true if I do this, if I had a cat and it said meow. So if I come down here and I say class cat animal public override void speak console dot write line meow Okay, if I did that, then I could come in here, and let's say we're going to make a list of animals. We're going to make a list animal, and that's how that's done. Animal list equals new list animal. And we could say animal list dot add new dog. Hold on. Huh? What have I done? Am I broken? Oh, hello. I'm an idiot. There we go. I'm slowly dying, apparently. I'm going to take a nap after this. So I'm gonna add a dog. Animal list dot add new cat as well. There we go. All right, so we got a list of animals. Analyst.add dog, analyst.add cat. Now, I'm going to do a for each here. We can use our for each that we did earlier. So we could say animal list dot for each. And then in this for each, we'll say console dot write line. Done. Okay. And then this, if our we don't need vehicle anymore. If our understanding of dog and cat, inheriting animal, and overriding is correct, then we should see bark and meow. Even though these are even though this is an animal list, and the animal list takes an animal, and the animal speak says bark. Oh wait! I gotta say animal list dot for each console. Oh, okay. This is a little bit. I can't actually do what I'm doing right now. I need to say. I need to use a regular for each or do a delegate, but in this case, we're just gonna say. This is a little more complicated than earlier. So, for each animal in animal list. This would be an animal in animal list. We'll say console dot write line animal dot speak. Oh wait, no, speak is already doing a write line. We don't need this. We just need to say animal dot speak. Okay. So we could have actually done it the other way, but that's okay. All right, so for each animal in animal list, we're going to say animal dot speak. What do we get? Bark and meow. So that's how that works. That's polymorphism. We have the ability to override methods within the original class and then reference those revisions later, even though we've converted the object to a parent object, such as animal here. All right. This is, I know this is a little bit heavy stuff, but it's something that you get into as you start to get comfortable with it. You start to understand it, it starts to make sense, and then it really, really helps you when you're writing code. All right, so let's do a mini lab. Okay, here we go. We need to create a person. So we're going to start over here. So we're going to make a person class. So we can say public person And this person is going to have a name and age, so it's going to be public string name and public string age. Oh, I don't know why I said public. Class person is what we want. Then we need a student class, which is a type of person. So we're going to say class student. And that student is going to inherit person. Okay. And that student is going to have a grade property. So we'll say we'll do A, B, C, D, F as the grades, which is how it works here. So in that case, we'll say character grade, because it'll just be a single character, A, B, C, D, or F. And then, hello, we've got an introduce method that displays student information. So just student information. So we'll put that here. So we will call this public introduce, public void introduce. And actually we want this to be static. So we can just do it. There we go. And then here we will say console dot write line. And this is going to introduce them. So it's going to display their information. So we'll say name. Let's see. This dot name. Wait, what? Why can't I not do this? Oh, it's static. Okay, my bad. I should have done static. We just need name. Name is age years old and has a grade in this class. Okay. All right. There we go. Now we need to create a teacher class. So class teacher will also be a person. And this person has a subject property. So this will be string subject. There we go. All right. So we've got a person class with a name and age. We've got a student class which inherits the name and age from person and introduces them. And then we adds a grade. And then we have the teacher class, which inherits the name and age from person, and they have a string subject. All right. So if I want to reference this, I can say person, my person equals new, and then I could say student. And now I've got a new student that's in the person class. And then I can assign something to that. So I can say my person dot name equals Adam Smasher. and my person dot age equals 33, which is my age, by the way, and this should be an int. And there you go. Now I can't do anything here because I have a person and not a student. So I could come in here and I could say student, my student equal my student equals new student, and I could do the same thing. My person dot name equals Pratchett, and then my person dot age equals, we'll say 27. And then we'll say my person dot grade equals, we'll give you an A. How come I can't do grade? Oh, because I didn't make it public. My bad. Here we go. Public character grade. Wait, how come I can't do it now? Oh, because I'm doing my person student. There we go. Yes, you are an A student. Absolutely. So Pratchett is an A student. And then what we can do is take Pratchett and Atom Smasher. We can add them to a list. And we could do whatever we want there. The cool thing that we're going to be able to do with this is we could make a class. We could make a class. And in that class, we could have an array of students and teachers. Or we could have the teacher assigned to that class, and then an array of students. And all that would be contained within that class, or the class object. And so I could reference it. So I could have a bunch of classes, and within those classes, I could see who's the teacher. I could see who the students are. And then within the teacher class, if I wanted to, I could have students. I could have an array of students. So if I just wanted to be able to go and look at teachers and see what students they were the teacher of, I could go look. Or I could go into a student and see who all their teachers are. And of course, that's getting into relationships, which is more of a database thing, and you would handle that slightly different than we've done that here. But bear in mind that we can put anything we want inside of these classes or objects, and they can be used anywhere we want in any context. So anytime you would have used any type, like an int or a string or whatever, you can use one of these objects, and you define them yourself, which gives you a lot of power and control over how you write your programs. If I don't like, let's say, I don't like the math. I don't like math dot pow or something. There's a math class in C# that lets you do things like powers and square roots and all that fun stuff. But I don't like how it works. I want to write my own. I could just come in here and make a class, my math, and then I can define my own methods. Like I could say public int add, and I would say int I int j. And then I would come down here and I'd say return I plus j. And I could just use this however I want. So I could come up here and I could say console dot write line my math dot add 1 and 3. Now, this is not going to be it's got to be static. I can use this static method to then just write it up here like this. And now I have the ability to just write my math.add 1 3, and if I run this, I get 4. So I can do all kinds of stuff. I could put all kinds of tools in a class that I want to use. I could call it class Adams tools. And then whenever I'm working with stuff, if there's stuff I like to do, Adams tools, I can just reference Adams tools dot whatever, and as long as it's static, which just means it's not using anything inside of the class, it's just something I can reference directly. And I don't have to have an object of the class. Like if I didn't have static here, I'd have to say Adams tools my tools equals new Adams tools, and then I could use the method. But because this is static, I can just say Adams tools dot, here's the static method, and it'll just work. Because I don't need to create a different version of it. It's just something I can reference from anywhere. So yeah, I could have all kinds of, I could have public, static, int, subtract, and I could do the same thing, int I, int j, do this, and then say return I minus j, bam, and I could do that too. I could say, there's 3, I have to add this, plus a space, oops. And then I could do Adams tools dot subtract 3 from 1. And I can run that. And now I've got 4 and 2. Okay. So, that's something that we can use these classes for. It's just a place to stick stuff. And if we use them as objects, then we have to instantiate them. We can put whatever we want in there, any kind of methods or properties or anything, and those will get carried along by any instantiation of that class. And if I have a million students, I can assign each one different variables, and those variables will follow those students around, which is really useful. All right, so summary. Object-oriented programming organizes code using objects and classes. Encapsulation protects data, so it prevents people from being able to access things within the class that we don't want them to access publicly. We've got inheritance, which promotes code reuse. So if I have a type, a class that I really like all the stuff in, but I want to change something about it for a specific thing, I can use I can create a new class that inherits from it, and I get all the stuff I already had, but I can make minor modifications, do overrides, add methods, that sort of thing, and I don't have to rewrite the class from scratch every time I want multiple things that have the same thing, same type in common. We've got polymorphism, allows flexible method behavior. Of course, I can change how the method works depending on what child class I'm using, and that will work perfectly. for different things, like with our animals. If we want dogs to bark and we want cats to meow, we can have the same method for all of them, and they'll do different things based on what type we've got in there. And then we've got, of course, object-oriented programming makes programs more scalable and maintainable. It's easier to work with somebody else's code when it's well organized and put into things that can be easily accessed and referenced, and you can make minor adjustments here and there, and you don't have to go back and rewrite the whole code just to fix one little thing. So it's very good. It's very good. Object-oriented programming makes programming so much nicer, so much easier to understand. You could do so many things. It's very powerful. It gives us all kinds of tools that are just baked in, and we can create our own things and be very creative with our code because of object-oriented programming. All right, now the take-home puzzle. Here we go. You are working for one of the largest international banks in existence. This bank controls countries. Empires rise and fall. Did I go over abstraction? Did I not go over abstraction? So abstraction is basically when we inherit from a class. I didn't cover it, and thank you for reminding me. So the thing about abstraction is certain things can be hidden from like your child classes. So I did kind of cover abstraction a little bit, but not directly. So within abstraction, the parent class doesn't have access to the child class's methods and stuff like that. So when we did the vehicle, we made a vehicle and we made it using the car class. The fact that I couldn't go in and use the method within the car class is abstraction, because the parent has no idea what's inside the child. It doesn't have the ability to do that. This is also available in reverse. So if I make something private to the parent class, I can't reference it from the child class. Now, there's ways I can do that. I can set it so that only children and the parent can see it as well. But that abstraction is just basically preventing the ability to see and modify methods and properties within child and parent relationships. That's abstraction. I should have made a PowerPoint for it, but that's basically what it is. We went over it. But I didn't call it abstraction, so it's good that you reminded me. If you hear abstraction, that's what we're talking about. Hiding things from parents and children. Don't hide things from your kids. Don't hide things from your parents if you're a kid. All right, great. Here we go. Take home puzzle. Right. So we're going to define a bank account class with properties for balance and owner. So we want to know who owns the bank account, and we want to know what's in the bank account, how much moolah. Okay, we want to allow deposits and withdrawals with validation. So they need to prove it somehow that they're the owner of the bank account. So you can try to figure that one out if you. I want to see how creative you can get with validation. We also want to make sure that it went through, but I mean, that's technically validation. But what I mean by validation is just we want to make sure that the person who's accessing the account is the person who's supposed to be accessing the account. Then we're going to implement an interest account, and this will be a subclass, a type of bank account that has interest. So an interest-bearing account. We'll call that interest account. And then we're going to use polymorphism. Remember, polymorphism to override a print statement method for different account types. So we want one to say this is a regular bank account, and we want the other one to say this is an interest-bearing account. Okay? So you'll override print statement, the print statement method. All right, take that home with you. This is the last of the Mohicans. No, this is the last of our fundamentals classes. After this, we will start getting into the fun stuff. I want to cover the docs for StreamerBot. We want to go through what we could do with StreamerBot using C#. We'll have some ideas on things that we can do. Look at ways that we accomplish certain goals within StreamerBot using C#. And we're going to mostly focus on StreamerBot and specifically C# within StreamerBot at first. And then if people are interested, we will also work within Godot, which there is a C# version of Godot that we can use. And the ideas of, by the way, Godot is a game engine, so we could make a game in Godot. But the basic idea that we want to kind of get used to, or the things that we'll learn from working in Godot, we'll be able to carry over to other game engines like Unity. So if you're interested in making a program in Unity, or you want to make a game in Godot, we can look at that as well. But that'll be much later. We're going to start out doing stuff with StreamerBot because I know a lot of people in the community are starting to use StreamerBot or are interested in doing certain things with StreamerBot on their streams. And we will use C# to accomplish most of those goals. And we'll be talking about that next week and for several weeks as we go along. So tune into that. Thanks for coming in. Thanks for hanging out. Could I show you the encapsulation slide again? Yes. Let me go back over here. Here is... Oh, that's the wrong view. Here we go. Encapsulation. There it is. So, encapsulation is just the access modifiers. And I didn't go over them all. We got public, private, protected, and internal. The two that we used today were public and private. Those are the most common. Public meaning it can be accessed from outside of the class. Private meaning it can only be accessed within the class. You've got protected, which means it can only be used by a class and the classes that it inherits that inherit that class. So that is how we can allow children to see through that abstraction layer using protected. And then we've got internal, which means that it can only be used within that program. So that's something that gets used outside of kind of the scope of what we've been doing. But essentially, when you create namespaces, you can create like when you compile your program, it becomes an executable, and then you can reference that executable from other programs, or it becomes a DLL. You can access that DLL from other programs, but you don't have access to things that are internal. So I can't go out and do something with something else that's internal inside of a DLL, for instance. If I reference it in my code, I can't actually access things that are internal. They only work within that program, that DLL. But that's way outside of the scope of what we have to worry about. But I went ahead and mentioned them just so that you know that they exist. I appreciate it. Thank you. Yeah, we'll see about the nap. Again, we've got the Atom Smasher stream starting at 4:30 today, 4:30 Central. So whatever that time is for you, do the math. But we will have the Atom Smasher stream. So look forward to that. It'll be lots of fun. And we'll see you guys next time for class. Oh, okay, you sent me a Discord message. All right, I'll take a look. All right, talk to y'all later.